Okay. Um, all right. So, okay. Thanks, Boston. Appreciate it. Let me share my screen here. So today will be a little bit shorter for physical science. Basically, Heidi had messaged in the general chat. She just asked, how do you figure out the excess reactant, how much of it you're actually using? And I offered an explanation, but I figured I'd show you guys a video of how to actually do it. So what we're going to do today, this question is the first question of the practice assignment that I had posted online. So we'll do this question together. We'll work through it. Uh, this is not for the one you have to hand in. This is just the practice assignment that I had given you. Um, the hand in is due this Friday. Yeah. So limiting stoic. So first thing that we always want to start off with whenever we have these types of questions is a balanced chemical reaction. So the new thing that we are going to do, which is calculating how much excess reactant there actually is, we're going to do that absolutely last. That's the last thing that you can do. And I'll show you and I'll walk you through how you do that. So first thing, balanced reaction, iron burns in air. So iron is burning in air, which is oxygen. And that is going to form a solid black oxide Fe3O4. So this little 2 is beside the oxygen because it is diatomic. The only thing that we need to do here is we need to balance this. So 2 can go in front of there, and a 3 can go in front of the Fe. So again, we know that this is an excess reactant question because we are given the number of grams of both of the reactants. So we were given that there is 60.0 grams of oxygen, and we were given that there's 50.0 grams of iron. Now the question is, how much iron oxide in grams is produced? So we want to know how many grams of this is produced. And then what we're going to also add on to this question is how much of the excess reactant is left over. And the reason that we're doing that is the first question of the assignment that you actually have to hand in, you do need to calculate and know how to calculate this part right here. So that's why I'm going to walk you through it. So first part, we have a balanced reaction. Second part that we're going to do is we're going to choose a method. Choose a method. So that's either method 1, 2, or 3. My favorite is number 3, so we're going to choose method number 3 to use. And the way that's going to work is we're going to start with Fe, the number of grams of that, and figure out how many grams of this iron oxide we can produce. And then we're going to start with oxygen and figure out how many grams of this iron oxide we can produce. So let's start with the iron. Iron, we have 50.0 grams of Fe times that line. I know that that'll convert into 1 mole of Fe. Molar mass of iron is 55.85. 55. Ooh, let's try that again. That's an 8. 55.85 grams of Fe. And then what I want to do is use my molar ratios to go from moles of Fe, which in this case, based on the balanced chemical formula, I have 3 moles of Fe, and I have only 1 mole of Fe3O4. We said we wanted to get to grams of Fe3O4, so we need to use the molar ratio and the molar mass. And so what we need to do then is we need to say, well, I have 3 Fe's, and I figured out over on the left side of this reaction that Fe has a molar mass of 55.85. And then I have 4 oxygens, and I know that oxygen has a molar mass of 16. So what I can do then is I can say 3 times 55.85 plus 4 times 16. That'll give me a total molar mass of 231.55. So this molar mass here is 231.55 grams, and that's of Fe3O4. I can calculate all of this out, and to do so, what I would put in my calculator is 50 divided by 55.85 divided by 3 times 231.55, and that equals 69.1 grams. 69.1 grams of Fe3O4. So again, that's one of our possible solutions. We are going to then figure out what the other possible solution would be by starting off with the 60.0 grams, 60.0 grams of O2. Again, I'm going to use my molar ratio based on the molar mass here. Oxygen has a molar mass of 16. 16 times 2 gives me 32 grams of O2 for every 1 mole. I'm going to use my molar ratios from the balanced chemical equation. And that was that we had 2 oxygens, 2 moles of oxygen for every 1 mole of Fe3O4. And like I said yesterday, from here on out, it's just copy and paste from what was above. We had 1 mole of Fe3O4, and that was being, or it had a molar mass of 231.55 grams of Fe3O4. Plugging that into my calculator, that would be 60 divided by 32 divided by 2 times 231.55. We get a final solution of 217.1 grams of Fe3O4. And so then what I would do is look at these two solutions and I would say, well, this one right here, that must be the final answer, the 69.1, because that has a smaller amount. And what that also tells me then is it tells me that the Fe is the limiting reagent. Fe is the limiting reagent. We know that because we were able to produce less of the final product when we started with this Fe. So again, we know that that is the limiting reagent. So now the last part that we want to do, we've actually answered this entire question already. We've answered how many grams of iron 4 oxide will be produced. We've answered that at 69.1, and we've also figured out that Fe is the limiting reagent. So the last thing that we want to do here now, is we want to look at this and say, okay, great, I know what the limiting reagent is, but can I figure out how much of this oxygen will be left over? Because if Fe is the limiting reagent, that means I have an excess of oxygen, meaning I have more than I possibly could need. The way that we're going to figure out, I zoomed in too far, we're going to figure out how much excess is left, is we are going to start with the limiting reagent. And then what we're going to do is we're going to go from grams of the limiting reagent to grams of the other reactant. So in this case, in this example, go from grams of Fe into grams of O2. And what that will tell us is that will tell us how much of this oxygen is actually reacting. So we had 50.0 grams of Fe. Time sign line. We've done all of these molar mass calculations already. We knew that that was 58.55 or 55.85, excuse me, 0.85 grams of Fe, and we know we can convert that into moles of Fe. Now, what we're going to do is we're going to use our molar ratio. So in the balanced chemical equation, we saw that we had 3 moles of Fe, and what we also saw was that 2 moles of oxygen will react with that Fe. So we have 3 moles of Fe. Sorry, I zoomed in really far there for some reason. And what we saw was that 2 moles of oxygen will react with that. Okay, and then we're in moles of oxygen, so we want to get out of moles of oxygen and we want to get into grams of oxygen. Again, this is O2. Oxygen has a mass of 16, so 16 times 2 gives us 32 grams of O2. Plug that all into your calculator. You have 50 divided by 55.85 divided by 3 times 2 times 32. And what we will then get is our answer is 19.1 grams. 19.1 grams of O2. This number here, this number is how much O2 reacts with 50 grams of Fe. Okay, so that number is telling me this is how much oxygen I need to completely react with all 50 grams of Fe. So in terms of wondering how much is left over, well, with the oxygen, we started with 60.0 grams of oxygen. We reacted 19.1 grams of oxygen. So left over, what that means, left over, we have 60 minus 19.1. 60 minus 19.1. So left over, we have 40.9 grams of oxygen remaining. And that's how you figure out the excess reactant. So what we did is we said, let's go from grams of the limiting reagent, this L with a circle through it, to grams of the other reactants. So we went from grams of Fe, used our molar ratios, and then got into grams of oxygen. And that told us how much oxygen could possibly react with 50 grams of Fe. If all of a sudden you get to this part here and your answer here is higher than the amount of grams you've been given in the question, what that means is that you chose the wrong limiting reactant. And in fact, some of your work up here was done incorrectly. But this right here just shows us that, okay, in terms of how much O2 is actually can react with the Fe, we know that 19.1 grams can react. We also know that we started with 60 grams, so we definitely did not use all of it.